Hello, discrete math fans. Let's define a few relations. And for each one of the relations, our goal is going to be to decide if it's a function. All right, let's start with this one. We'll define a relation S. And the ordered pairs in S will be 2, 4, 3, 4, 1, 5, negative 5, 2, and negative 4, 1. So when we use this phrase, define a relation, then the text here is giving you what the relation is. This is the definition of the relation. And we're going to say that the domain of this relation is the set A, and the elements in this set are negative 5, negative 4, 1, 2, and 3. And we'll say that the codomain of this relation is the set of all integers. All right, so we're coming up with this relation. And now that we have defined this relation, let's try to determine if it's a function. So this is a function, and let's try to explain why. Notice that each element of the domain corresponds to exactly one element in the codomain. And so we should be able to see that here. For instance, take the number 5 in the domain. It shows up once as the first element of an ordered pair. And we can continue like this. Like, what about negative 4? Well, it shows up once as the first element of an ordered pair, and that's true for all of them if you go through all 5 elements of the domain. And one of the things that we should also note is that it's not necessary for the corresponding element in the codomain to be different. See here that 2 and 3 get mapped to the same place. That does not mean that this is not a function. So that's not a requirement in the definition of a function. So that part's okay. So there's no problem with the fact that 2 is related to 4 and 3 is related to 4. Let's talk about the circle relation. Now, we've defined this on a previous video. If you'll recall, the way we defined this was that C is a relation from R to R, and it's defined by saying that for any x and y in R cross R, x and y is in the relation means that x squared plus y squared is equal to 4. So we know graphically what this looks like, that an ordered pair is in the relation if and only if it lies on the circle defined by this equation. Now, this is not a function. And the way we can see this is that 0 would have to get mapped both to 2 and negative 2. And we know that if there is an element in the domain that's related to more than one element in the codomain, then the relation is not a function. Now, in pre-calculus, you would have described this using the vertical line test, that if you draw the graph of this, it fails the vertical line test. Okay, here's another one. We'll define a relation R from the natural numbers to the natural numbers by saying that x comma y is in the relation provided that y is equal to x minus 1. All right, so just as before, the question is this a function? Okay, this is not a function. What happens if we plug in x equals 1? The corresponding codomain element would have to be 0, but 0 is not a natural number. Essentially, the idea here is that 1, which is in the codomain, does not get mapped to anything. Now, we've talked about arrow diagrams. This is yet another way of defining a relation. So we'll define a relation by using this arrow diagram. So that tells us what's in the relation. This is a perfectly good relation. The question is this a function? This is not a function. Now, there are 2 reasons this is not a function. Let's give both reasons. Now, the first reason is that we see from the diagram that there are 2 different arrows that come out of 4. That is to say that 4 is related to 3 and 4 is also related to 6. And this can't happen with a function. Now, that's enough to say that this is not a function, but let's go ahead and give the other reason. The other reason is that the element 1, which is in the domain, is not related to anything in the codomain. Now, that would need to happen in order for this relation to be a function. So those are two different reasons that make this relation not a function. Okay, that's all for now.